Hello, this is Pramiti, Aaron, and Joseph from Group 2. Today we are going to talk about our case study on Flask. So, Flask is a web-based micro-framework that is written in Python. Flask supports developers with several packages to build web applications. It is mainly designed for rapid development of a web-based project, giving the developer only what they need for a particular project, which can be appealing for relatively entry-level developers. There are many plugins and extensions available like object relation mappers, upload handling, and various open authentication that are supported by Flask to extend application features. All of the assets could be influenced by specific implementation of Flask in Python program. Due to the nature of the Flask design with several modules, many features are left to the end user to implement, which could be important assets to the project. As a micro-framework, third-party plugin implementations to extend functionalities of Flask is heavily dependent on user-contributed resources for all sorts of important functionalities. External libraries, which are the extended functionality of Flask, is often an important base for other projects. Projects like a picture viewer program, users can use a variety of resources depending on the project. Another assets, which is databases, are often integral to websites. For user information postings or other store information, so database access files are one of the assets for Flask.
Okay, so among the 25 top vulnerabilities we found in the Flask project, let's talk about two of them. The first one, CVE 2021-33026, had a risk score of 7.5. In this one, the threat actors could gain code execution privileges through the Flask catching extension. So this extension uses the picklin module from Python to serialize objects. The attacker can get access to the catch storage through that. So an attacker could get access and compromise the integrity of the catch by executing their own Python code. They didn't have to go through authentication, and this is a relatively easy vulnerability to exploit. So attackers do not need to be experts to do this. So that's probably why the rating is so high. The next one is CVE 2022-25510. This is where there was a hard-coded Flask secret key inside of a server, and it allowed the attackers to make their own cookies and change the UID of the user, and it helped in bypassing the authentication or in the escalation of privileges. So this vulnerability was discovered recently, and there were 4 relevant places where the Flask secret keys were hard-coded, as indicated here. Okay, so on to the general architecture. Flask is a model view controller design pattern, and this means that the user interacts with the controller, which manipulates the view. And this could be any kind of web application. The Flask application is then mostly on the model side, which influences the controller, etc. So Flask is also thread safe, which means that it's inherently designed to avoid race conditions. And this is great for people who aren't comfortable with doing threading and are not sure how to do it safely. When you make a Flask application, you have one central object that's called, and that implements a Flask application. And there can be multiple applications built to respond to different requests. So when you're developing using Flask, you can create a subclass of the main class that is, excuse me, a subclass of the main Flask class that can be specified according to what you need to do. Along with this, there are many plugins that give developers access to different features because it is a micro framework. It's relatively light. So for security, there is the Flask security plugin. For example, the standard Flask micro framework does not include session-based authentication, but you can do a plugin that will give you that. And Flask is basically a wrapper around two main libraries that are also developed by the Palettes project. The libraries are WorkSug and Jinja2, and they're important to the whole architecture because um, these libraries are also they implement some WSGI utilities. That's the WorkSug library, and within that library includes there's functions like routing functionality, WSGI helpers, path encoding, HTTP utilities like parsing headers, and middleware like an HTTP proxy. So that's why the libraries are so important. The Ninja 2 is a template library, and it's used mostly for the fast loading of application data. It's not separable from the Flask application though, so it's you're always using it unless you wanted to have something different. But the Ninja 2 has to be in with the implementation. Um, there's also a JSON module for handling JSON files, and that's how they do their encoding and decoding of objects. There are also some special cases of serialization built in to handle older JSON files, and the application, or excuse me, the project as a whole adheres to the principle of keep it simple by reducing complexity, and that's where the single responsibility principle comes in. So essentially, this means that each subsystem has one main purpose and responsibility. For example, the scaffold.py module provides much of the data structure for building web applications, including holding application functions, and the session.py uh, module, for example, tracks cookies, etc. Okay, and this is from our threat report, an example item. Basically, the Flask application instance doesn't include a data abstraction layer in general, but it can have something like a SQLite, or the developer might build it in. And excuse me. So it's vulnerable to typical SQL injection, and the malicious code might be input into some form on the web browser side, and executed through command line. That's or executed by other commands. And again, it's particularly vulnerable in this because the developer would have to add an entire abstraction layer to have a buffer.
For the inspection, we wanted files that are clearly important for the user and applications with a significant amount of code. We also wanted to inspect files that exchange information in some way, either web request or with the file systems, because that is where important vulnerabilities may lie. In the end, we think we made good choices and some important observations, and we feel we made valid critiques. That said, there were some important challenges we faced. The first was technical debt. There were things about the source code that we could not understand through static inspection alone, and there may be valid historical or design reasons that we did not consider. Secondly, Flask was more of a wrapper about some libraries like WorkSug that was initially realized. These libraries have important functionality that we did not examine. Lastly, the most importantly, we felt the design concerns we had are mostly consistent with the design philosophy of Flask, which is laissez-faire and leaves a lot for the developer. We found these to be at odds with a security mindset. The bandit.py is a command line static analysis tool for finding security vulnerabilities in Python code. It gives the possible vulnerability and the confidence as a way to help with false positives. Running it for the Flask code, most of the vulnerabilities relate to the use of the asset statement. Python code has different modes of execution that it can be run in. If Flask is not run in debug mode, the assert will be ignored for performance reasons, and things the developer thought were being checked aren't opening the door to exploitation. The others relate to laser issues that we also identified notably before running Bandit that will be discussed in our inspection.
This is an example from wrappers.py in the source Flask GitHub folder. We chose this file because it holds the request and response objects, which are central to every Flask application and web interaction. We feel this is a good example of a design concern that we have. There are 3 variables here that are initialized to a Python none. What struck us was the lack of immediacy in the error handling, particularly in the routing exception. The request object will be the point of entry for every transaction, and we were struck by the lack of immediate handling and validation. Again, there may be design and usage considerations that we do not understand, but Flask objects are meant to be flexible and inheritable, so we felt this may be too hands-off in this design concern that we have. This example is from config.py and provides several functions to read configuration files, something that is common in many applications. 2 things struck us in config.py, and the first is from the function from pfix.env, which loads environment variables. The loads function in the try except block here is a callable set to the loads, JSON.loads function. But as you can see, it never raises an error, something that is at the very least bad practice. This would make more sense if it only avoided one particular error rather than all errors. To the right of the image is the bandit report showing that it is a improper check or handling of exceptional conditions. More egregiously is the middle example from the from Python function. If you're not familiar, the exec function here on line 185 is a pre-built Python function that executes any string of valid Python code. So the function here will execute any code that is contained in the file. We believe it would be possible to put malicious code into the configuration file, and it could still seem to be working if everything else in the file was unchanged, unbeknownst to the developer. While it may seem unlikely, directory traversal attacks are possible in Flask and must be actively prevented. So it is hardly out of the realm of possibility that a file could be compromised in the right setting. To the bottom right is the bandit report showing that the severity is meeting and it violates the CWE improper neutralization of special elements used in an OS command. What makes these 2 examples most frustrating is there are plenty of libraries in the standard library and third-party libraries that provide configuration file functionality without the security risks. JSON has been a persistent challenge for Flask. If you're not familiar, JSON stands for JavaScript Object Notation and is a text-based way to transmit information. It is extremely important for transmitting information on the web and is therefore very important to Flask. Flask makes heavy use of the JSON library in the Python standard library. There are 2 CVEs for Flask that involve JSON and they overlap. Here's a description from CVE Details. To the right is a list of 276 issues posted on GitHub that involve JSON. Some are trivial, like typing issues or bugs, but it is clear for such a mature project that JSON has been troublesome. The CVE and the fix, according to the pull request on GitHub, was due to a lack of string character validation involving UTF-8, 16, and 32 characters. The JSON standard calls for only UTF-8 to be used, but Flask, according to the maintainer on the GitHub pull request, allows for all types, presumably to allow for things like emojis. The fix involved using a validation function that was in the standard library. On one hand, character, string, and validating those have always been a challenge for developers in any language, and one could be forgiven for thinking that Python takes care of everything because it seems to. On the other hand, this is reflective of the laissez-faire attitude Flask has, and it does not aggressively validate input as a result, and vulnerabilities appear. Flask in many regards is a great project. The code is organized and separates concerns. It is well commented, even typed, something that doesn't have to be done in Python. It is also widely used and actively maintained with a rich community. From the start of the project, it seemed like Flask is the go-to for Python web projects. But in examining this code base from a security perspective, we were struck by just how vulnerable it makes a Flask user. It is almost insecure by design, making it incumbent on the developer to invoke security features. And the design of Flask does not reflect a security-first perspective. All the design issues we found reflect this hands-off attitude. Going forward, we view the design trade-offs of Flask very differently. It is meant to be lightweight without asking a lot of the user. But the costs of this are high and can be paid for by the user and the user of Flask projects.
So, in conclusion, Flask is a great project for all the reasons we mentioned. It is a well-built and maintained project that many projects could learn from it. But we feel it leaves too much for the developer, especially in terms of security. Not only must a developer actively work to make it secure, but also be aware of all that needs to be done, making it most inevitable that a Flask project will have some vulnerability. Given that Flask is appealing to entry-level or immediate developers, this is a concern. Many of the flaws we found, like not immediately raising errors or the use of execute, are less flaws and are largely reflective of a lack of security mindset. Security is simply not a priority. Our thoughts and feelings on Flask have definitely changed from where we were at the beginning of the project. These are some of the references we used for our case study. Thank you.